Okay, so today we're going to be making the game Snake from scratch. So follow me as we go along. First of all, we need to define the memory storage for the length of our snake. Here we will store the coordinates of each part. Let me make a comment here. The coordinates x and y, then the direction dx and the direction dy for where the head of the snake is moving to. To do this, if you remember, we have to allocate some memory, so we use the word alloc in immediate mode, and I want to allocate 1000 bytes in immediate mode as well, and I want these bytes to be filled with zeros. So we have to do this word here called address fill. If you press the source lookup, you can see that this takes a character, a number, and an address. So the character will be 0, the number will be this 1024, so we need a copy of that, and the address will be provided here in alloc. So when I call this and press F5, we will have allocated the address for the snake. So let's just look at the address here in immediate mode, and we have an address on the top of the stack. Next, we need some variables, so let me get rid of this. We need the head of the snake, and we need some food, and the head will be a reference to the snake memory, and food will be a variable which you type like this, var, or you can also compile a -1 in assembler mode. Now we need a way to display the food and the snake, so I'll start by typing .food as a new word, and I will fetch food as a reference, and I will fetch the first 2 bytes as a half, and I need a way to display or to convert this at half to a coordinate xy. So I will add a new word called pause and semicolon, and let me go up here and define pause, which will take the word that we have on the stack and output an x and a y. So we need to duplicate that number on the stack, get the byte using byte and, which if you look at the source is just ff and then swap it, move the other byte down, and byte and as well. So if I call let's say, let me compile this, if I call pause with an address of, let's say, 1012, we will get 12 on the stack and then a 10 on the stack for the x and y. So let me just drop those and continue here. Now I want the food to be the @ sign, which is the character number 64, and we will emit that character using .c, but we need to position it where the position is, so we will use the word atr, which sets the x and y position for the text. Now let's try it out. I will clear the screen in immediate mode, do .food, and then display the screen, and you can see it's down here. So I press escape and I'm back to the editor, and we need a way to generate new food, so let me clear that. I will type food plus, and I will define this as 2 random numbers, and the range of the random number will go, or rather it will be wrapped around let's say a 16 by 16 grid. So our screen is 640 and we want to divide it by 16, that's 40, so 40 mod and then another random, and 480 divided by 16, that's what, 120, no, 480 divided by 16, that's 30. So random 30 and mod, and I will shift this one 8 because it's a byte. I will order them together and I will store them inside food as a reference. Store drop return. Now every time we call food plus, we will get a new value. So let's just say clear food plus, we print our food and we display the result, and we have a different food, but it's giving me an error here. So let's see, where am I wrong? So I'm getting a random and I am modding it with 40. Oh, it needs to be an absolute value, so random absolute, and let's give it a try. Okay, but now the range is just too small, so we have to multiply by 16 the position here. So byte and we shifted by 4, byte and we shifted by 4, that's multiplying by 16, and now we should have a 16 by 16 grid on the screen, and our food is all over the place now. Okay, next we should be making our loop and printing our snake, so let's do that. Let's make the final function here, call it snack, and here I will do the dot food, and I will make another word called dot snake to print the snake, and dot snake. So, and I will jump again to that word by coloring it in gold, so this will generate a self-looping function without the tail call wasting tail calls. So now let's render our snake. So if you see up here, we have x, y, dx, and dy. The dx and dy are used to add to the direction of the snake, but we can also use that to check if we should not render the rest of the snake. Let me show you how. So first, let's say we get the x and y position. So let's say that we are using the A register, so A at 2 plus, and this will give us the x and y position. I will get the position and set the cursor to the address. Then I will fetch it again and see if that pointer is valid, because if it's not valid, it won't have a dx and dy direction, right? So I will ask, is it valid? If it's valid, then I will print the x, an x for the snake, so that's an 88, and I will print that character 88. I will also want to loop again to see if there are any more parts of the snake that need to be printed. So I will do a snake, because now our A register is pointing to the next iteration, or the next part of the memory structure, right? So here I will just say snake, and I will push it into the A register, and here I will pop it back, so everything is conserved, right? So let's just give it a try. Do snake. Oh, and I need to pull the for input side, so I will type exit and put it here first. This will make it so if I press escape when there is a loop, everything will just stop and start bring me back to the editor, right? So I need to food, and I will need to display that food, and I will also need to clear the screen. So let's just press F5, and we have our add, but our snake is nowhere to be seen. So let's just go and debug that. So here, let's just see where we are at. We got a 0, position 0, and ATR 0. So if I see where is it, well, of course it's not going to show anything, right? And of course it's not going to show anything because if I look here at the add +2, it will be a 0, and this is asking, hey, are you valid, are you a number? And of course it's not, so it will return. So we have to do a little bit something else. Let's just make another word called loop, and instead of calling snake, we will loop back to the loop word. So our first execution will be setting some memory here in the snake. So let's say that whenever the game starts, you will have the snake will start at the 0 position with a direction to the left. So let's say the left in x will be dx, so that will be 1 0 1, and the dy would be 0 0, so 0 1. If I move the cursor, it will just go back to 1, and I need to shift it because these are the x and the y position, and I will OR them and store and drop into the snake. And now let's see if it renders. So let me put the display flag here, and you can see we have an X, but it's not very clear, so let me just do it in a different color. Let's say 9 color store, that should be the green color. And for the food, I will have it in light green, so that would be 1 color store food. And let's see, now we have them one on top of the other, so maybe I should just get a random position. No, random not, because I will have to do the 40-30, so maybe just shift it by 8 and have an input here. So let's say I want the snake to start at 100 by 50, and I can't see the snake, so because it wraps. Okay, so let's say I want to start at 15 and 15, and still nothing. Let's see what I'm doing wrong, and I'm getting some really weird stuff here. So because it's not immediate. So if it's immediate, I should have FF OR, and if I go and look up here, I have the direction now. If I press F5, now you can see we have the snake and we have the food down here. Okay, so in order to move the snake, we have to add the dx and the y to the x and the y coordinates of the snake. So let's just make a word, call it step, and in step we will have head of the snake, and we will have to access x, y, and the x and the y, and we have to add them and store them back into their memory. So we will have 2 heads, and we will store it in A and store it in B. Remember, A for reading, B for storing, but we can also use the R open bracket, which is just a macro for A and B, and it has to be a macro. So we have A, and I need to fetch a byte, and this is X, and I need to fetch another byte, and this is Y, and comment that I need to fetch the third byte, this is the X, right? So let's just start our testing like this. Let me put step down here and start debugging. Press F5, this is the address for the head. Press F5, we have two heads now. I'm looking at the byte, that's an F, that's a 15, and we have X and Y, that's two 15s, and the X should be, and oh, I need to increase the pointer, so A at plus, A at plus, A at plus, and now it should be the proper order. We have a 1 on top, that's the X, so we can start adding them. And remember, since we have a 16 by 16 grid, we have to do a mod, and let's see, now we have 16 on top of the stack, and we have to store that back in X. So if you remember, we have A and B. A is now way ahead, but B is still pointing to X and Y. So if I store 1 byte, that will be stored in X. Then I fetch the next byte, which will be the address, the DY address, which is 0, and we have Y on top of the stack. I add them together and mod them with 30 for the Y direction, and it's just an F again, and I compile one, storing again into and into Y. So this should let's see, this should give us, let's move this one down here just for clarity, do another debug, and we're back to where we were. So our snake, if I press F5, our snake should move, and it's moving diagonally, so that's probably I just did something wrong here. So let's just try it again. A at plus, A at plus. Oh, because I am adding them, I am adding to Y, right? So I need to have a rot to bring the X forward. Maybe change this to make it clear. So 10 is X and 15 is Y. If I put a rot, I will move 10 to the top of the stack, add it to the X, and then I will have Y in the top of the stack, which is 15, and the dy, which is 0. If I press F5, now it's moving to the left, to the right, but it's moving way too fast, so maybe we need to do a little sleep here. So let's say something like this, 100,000 sleep, and that's way too slow. Let's say 50,000 sleep, and that is a little bit more tolerable, maybe 80,000, and okay. Now if we adjust the sleep parameter, maybe this could be the difficulty, so we can make a word to make the game more difficult. So let's say hard, or maybe level would be 10,000 multiplied by whatever. So let's say level 1, and when we are making the snake, we can set the level, so level 5, and I will say level store v, which will store in the first slot of the word. We'll make it as if it were a variable, and here I can just call level sleep. So let's just see the level, and we have 50,000. If I change the level to 6 we'll have 60,000, right? So we are level 6, and let's say we are level 5, we are level 1, and it's huge difficulty, so let's just put it at level 8. Yeah, level 8 seems good. No, level 7 I mean. and continue. So okay, now the snake moves, but we need to have some sort of input to, you know, control the snake. So let's just make a word called input, and we read the keys by using the key and question mark, and let's just do a case statement. Okay, so next we have to get the input keys, which are A, S, D in the bottom row, and then W. So let me just comment this, and I'll show you something. If you press escape and you type wait key, press space and then type the key you want to know the code for, it will give you the number of the key. I pressed A and that gave me a 97, so that's 97 for A. Then wait key and S. I'm touch typing here, so I probably make some mistakes, and do it again. Wait key, ASD, okay, that's 100 as a number, and then W, wait key and W, that's 119. Then I start making cases, so case off in immediate mode, case off, and then case and case, right, and start pasting them around, and move this one down here, case and case, return, and so let's see this. Okay, so we have dx and dy, right? So let's say that the positive direction will be 1 and the negative should be -1 because we are adding them. But if you look at -1 in hex, it's a huge number, but we are using bytes, so we will have to get a little bit creative and sign extend the -1 here in step. So let's just do a quick sign extend word. Let's call it sign extend 8. So sign extend 8 will shift the word left by 24, 0 shift left, and it will shift it back, but it will be an arithmetic shift, and that should be our sign. So let's just test it. Let me put a space here so compilation ends in the plus sign here. Press F5 to compile, type 255, that's FF, and SX8, and it sign extended the FF. So here when I get the DX, I will sign extended SX8, let's say 255 SX8, and let's say if I 1 SX8, and it's just a 1, okay. And I will also sign extend the DX, the DY here, okay. Now back here in our input, now we know that 1 is positive direction and FF is the negative direction. So I will get the head, I will add 2 plus to the head, and I will store the half word and drop that. So here I need to set the directions. So let's say A would be in this in the left direction, so that will be a -1 in the X, so that will be FF for the X and 00 for the Y. If I convert it to hex and move the cursor, it's just an FF, and that will be stored as the half word. That's 2 bytes in the second byte of the head. So I need to repeat this for all the cases. but instead of copying and pasting or typing it again, I will just make a word, direction store. And notice that even though we are inside a word already, and even though we are inside a case statement, I can just go ahead and define new words. That's just the flexibility of the language. So S would be the down case, so that would be -1 in the Y and 0 in the X, and I will call the dir store. And D would be 1 in X, so that would be just a 1, dir store. And W should be a 1 but in the dy, so that would be 1 and then 0 0 as a hex, remember, dir store. And let's just give it a try. Hopefully everything works well. We press F5 and it's moving. If I move it to the other direction, and it's moving. Okay, it's working. Okay, now we have to make a way to eat the food now. Let's press F5, and I think we need to call food plus just to change the direction of the food. Food plus, let's see, and if I press it again, okay, it's all over the screen, it's working properly. Now I move the cursor, and I think it's a bit too fast, so let's just make it level 8, and I move the cursor and I get it on top of the food, and I need to check if there is a collision on top of the food, right? So let's do that next. Let's just make a word called on food, and what this will check is if both directions of the foot and the head are in the same place. And we can do that. We don't have to check for X and Y, we can just check for the half word, right? So at half of the head and then food at half, but food is a reference word. And if these are equal, that means that we are on top of the food. So let's just do a breakpoint and do like something like a 4 here, put a 4, and I need to call it, of course. So before sleep I will call it, no, after step, and I will call it on food, and it's checking, and let's see if I get on top. No, I can't get on top, and it broke. Okay, so that's working. Now when we are on top of the food, we need to eat the food, so let's just make a word for eat, and when the serpent eats, the head will move, so we start with the head and we will move it to the next address in the memory structure. So we will use store v. We will say head plus 4, and we will store back into head store v. So let's see, on food, and if we are on top of the food, we eat. Or we could even do it like this, right? Because the definitions fall into one another. So whenever we are on top of the food, it will jump here and it will go to this definition here. So let's just see if we can get to it, and we are good. So head 4 plus head store v, but I think we also need to store the same values of the head, otherwise it won't count it for when we are rendering. So instead we're going to say dup at dup 4 plus head store v at, we fetch head and we store and we drop that. Now let's say dup 4 plus let's just do a debug here, and since I don't want to go ahead and run until I get the food, I will just call it here eat, and let's see if it's all working. Okay, for plus head store v, I fetch the head. Let's see what happens if I fetch the head here. Is 0, and of course I have to call it down here because I hadn't even set the parameters of the head. So I set it here, and let me just call it down here. If I fetch it, I get the parameters properly. So we get head top plus plus 4, store the variable, fetch, and store it in the head, and we're good, right? So if I call it and put a debugger here, nothing on the stack, we're clean. So let's just test it and see if it works. Okay, now if we press F5 again and we go and eat, you can see that the food had an X on top of it, marking it as the position of the head of the previous head, but we haven't moved the rest of the snake yet, so that's to be expected. Instead, we need to drop it. We need to call food plus to get a new location for the food, and I get new food and the remainder of the snake. Okay, now in order to solve that, we have to move the body of the snake. So let's do that next. Let's call a word called move, and what move will do is check if we are the head of the snake. So let's just check if we are the head, and let's say move takes an address, and let's say that move will wrap around itself like a dot snake that we have up there. So we have to duplicate the top of the stack, check if we are the head, and if we are not the head, go ahead and continue. Then we have to check if the snake memory structure is at the end. That means if the dx and dy are not valid, so we say dup to plus at half, and we check if it's valid, right? So if it's valid, we continue. Now you notice we are chaining a bunch of ifs. That way we don't have to make some other word just to check if the snake is valid. So we can keep it in relatively one line. Now, how does the snake move, right? So the head moves, and the body had the previous position of the head. So on every step of that the head moves, the positions of the body should get the position that would come next, right? So if we have an address here, and if we get the next position, that would be, we duplicate that address, we add 4 to get to the next position, we read that to get the values of the next position, we swap that, and we store it in our current position, right? Then we need to continue doing that until we are the head of the snake. Then we won't do that anymore. So to go to the next position would be 4 plus, and to continue doing the thing, we will call move again in yellow to make it a jump, right? And that will leave us with an address at the end of the calculation that we have to drop. So let's just say that we put move up here, and on every step we move the tail of the snake, right? So here, let's say here in step we say move, and we are calling move with the address of the snake. So let's see if it doesn't crash. Save, and let's eat some food. And I'm almost getting it. Damn it. Okay, now we have the tail going with the food. So the tail and the eating is working, but we need one thing we are lacking is self-collision, so that should be the next part of the that we should write. So let's get onto that. Let's say here on food, let's make another one that says on self, and we start by doing a comparison if it's the same head of the serpent. So dup head equals 0 question. So if it's not the head, we continue along. Then we want to see if it's a valid piece of the serpent, so 2 plus add half, and if it's equal, we continue along. Now you may notice that we are actually repeating the same piece of code up here in move, so we can take this chance and do a little bit of refactoring. So let's just make a word called valid instead, and valid will be dup head equals, and since we have 0 question mark, we have to compare it with 0. Then we will say over 2 plus add half, and if this half is greater than 0, so if 0 is lesser than this half, and we add them together, and this will be our valid word. So let's just change it for valid and test it, see if it works, and it's working as it should. So we can just go ahead and put it here valid as well. Question mark. Then we have to check if the position of the tail of the serpent crosses with the head. So we say head at half, and then over at half, and if these are equal, then the game is over. So game over, and I print it, I display it, and I want to call the command line just to wait for some input for the player, right? And I make this a string, and that's it. Otherwise we add 4 to what we have. So let's see, that's it. And oh, I'm not calling it, right? So I have to call it, and well, let's just finish here. Otherwise I add 4 and jump again on self, right? So let's just try it out. On food, on self, drop, and I call it with the reference to the body of the snake. So let's just go ahead and see if it works step by step. Okay, that's valid. No, it says invalid, right? Snake on self. Let's see. Okay, let's game over. Oh, that's it for the tutorial. No, I'm just joking. We have to put it somewhere else. Instead of putting it here, let's just try here in step. Where is the step? Step, where are you? Let's see. oh, step is over here. Okay, so instead we just call it here, and that means we have to define this up here. So let's just put it there, and let's give it a try. Let's eat something, and it's working. And if I press back, I collide with myself. Okay, now let's do a little cheat here. Let's just add a way to increase the food, just so you don't have to, you know, see me chase the food all the time. So whenever I press space, that's a 32 key, the food should increase. So let's just go like this, and let's see if I can collide with myself. Let's just make it longer, and okay, game over. So with this, the game is pretty much done. So let's just implement some scoring. So let's just say, let's say that our score is called count, and it's 0, and we have a high score. And let me show you something really cool. Whenever you have a string, this is stored in source code, but you can actually modify those strings via code, and that gets saved as if it were a variable. So let's say we have a string that is all zeros, so 0 insert character, 0 insert character, 0 insert character, and we have 3 zeros, one more, 0 insert character, and this will be our high score that will get stored. So let's just make something that changes that. So whenever you say score, you will get count, you will add 1 to count, so count plus star v, then you will get count, and you will get the high score as if it were a reference. Oh no, as if it were just a call, because it will put that address on top of the stack. You will read the half word of that address, you will get the maximum and store it back in high. High, store, and then drop, return, right? So whenever we eat, we increase the score. So let's just give it a try. Oh, but we need to print it as well. So let's just say score, and up here say message at 100 ATR. So we will print count, and we will also get high, we will get the half and print it, and I think we need a space, and that will be it. So let's just go down here. After clear, we print the message, and let's see, 1, 2, and if I just increase this by a lot, let's say like this, and now you can see it saved the score, right? Okay, so the only thing I think would be useful here would be to call message when game over, and we do a carriage return, and let's just increase the little cheat, and we get game over when we had the message. Other than that, I think we're pretty much done. And as always, leave a comment down below. If you aren't subscribed, please do, and check out my Patreon, links below, and I'll see you in the next video. Bye.